As I mentioned in previous slide, after I pushed enter, another windows will pop up. So I change the directory to Jupyter and by cd command, and this is what you can see. When I put the Jupyter Notebook port 8888, this is gonna happen, and we can see a bunch of links, and there's a token, and I need that specific token for entering into the Jupyter Notebook port on cloud. So I copy that token because I'm gonna need it in next processes. Right now I need to open another SDK shell, uh, and by using this command, uh, this is a different command. Look at this. There's a big command, and the difference between this command and the previous one is that there's an L8000 and localhost 88 that we need to put this command on the new SDK shell, and by pushing enter, uh, Windows pops up. So we will let them to be open. Then we're gonna go to this link, HTTP. Localhost is 8000. When I push this button, it's gonna ask us that what's the token. So the token that I obtained in my previous slides, I'm gonna copy that. I'm gonna copy that token, and when I push enter, this is gonna happen. So right now you can see that I opened Jupyter Notebook on my virtual machine by using those commands. So this is the page that I can see. If you look at it, you can see my different works in IPYNB files here. Also, you can see my final projects works here. Now that we are ready and we opened our Jupyter Notebook, and now it's time to import the required libraries in our Jupyter Notebook. We need libraries like Pandas, NumPy, Matplotlib, and TensorFlow. And I need to mention that as Dr. Wen instructed, we need to use TensorFlow 1.15.5 version. And look at this picture. By looking at this picture, you can see that I'm using this version of TensorFlow for my project. Now here I'm going to load my dataset into the Jupyter Notebook to use my codes on it for making my CNN model. If you look at this code, you can see that this code is provided by Dr. Wen, and I'm going to use these codes for importing the dataset and making the dataset ready for my purpose of the project, which is classification and image recognition. If you look at this slide, you can see that uh, I displayed some pictures to see this is our data set. So you can see a bunch of simple and low resolution pictures, and we can see that our data set is working, and we can go and proceed to the next step. Uh, for my project, first I performed a one-hot encode on categorical data to make 10 different classes. And then I set up the image dataset, which is a collection of 60,032 in 32 pixels color images in 10 different classes. And each class has 6,000 image per class. I created the training and test data set, and now the data is gonna be ready to use in machine learning purposes. I also created two placeholders, x and y underline true. X holds a two-dimensional array data and the shape is non comma 32 comma 32 3. Non here means that the batch size can be any number, so we can use different batch sizes. The second number shows the height of the image and which is 32 pixels. The third number is the width of the image, which is also a 32 pixel. And the fourth dimension is 3, that shows the number of color channels for RGB images. About y underline true, y underline true holds a 2D array of floating values. The shape is uh, non comma 10 in a bracket. Non means that the batch size can be any number. We talked about it. And 10 here shows the number of classes we have in our model. Now we can start building our CNN model, our convolutional neural network. So in my there are a lot of there are a couple of layers in my CNN model convolutional neural network. In my input layer, I fed data with the shape known 32, 32, and 3. I talked about this. Known means that the batch size can be any number. And the first number shows the height of the image. The third one shows the width, the width of the picture, and the last number shows the three channel or three colors of the RGB images. We have another layer named convolutional layer 1. This layer has 32 filters with the size of 5 in 5 pixel and 3 different colors. So the shape is gonna be 5, 5, 3, 32 in bracket. So height, width, and depth of the input tensor is respectively 5, 5, 3, and 2. In our convolutional layer 1, we use ReLU activation function, and this activation function is a non-linear function that can help the model learn from the input feature. And the output of this layer has a shape of non-28, 28, and 32. Then we are gonna make pooling layer 1. In this layer, we reduces the spatial size of outputs of the previous layer. This max pooling layer decrease the complexity of the model by taking the maximum value within a 2 by 2 width filter, and this means that this layer make the data in halves. So the output image has a shape of known 14, 14, and 32 in brackets, and you can see that there's a decrease in a spatial size of the data here compared to the previous slide. Then we are going to go to the second convolutional layer. Uh, this layer is the purpose of this layer and the task of this layer is like the first convolutional layer. So this layer applies a set of 64 filters with the same size of 5 multiplied by 5 pixels to the output of the previous layer. The output data of this layer has the shape non 14, 14, and 64. This layer also uses ReLU activation function that is a nonlinear function and that can help the model to learn from the input feature. Then we are going to have the second pooling layer. This is another pooling layer and it does the same as the first one. This is another pooling layer. It reduces the spatial size of output of the previous layer. This max pooling layer reduces